Hi, and welcome to our first algebra lesson from Chapter 1, Connections to Algebra, Lesson 1.1, Variables in Algebra. So to begin with, we need to first define and understand the idea of a variable. So our simple definition, which I provided for you, a variable is a letter that is used to represent one or more numbers. And what gives it its name variable, if we think of the letter x. In one mathematical problem, x may equal the number 5. That does not mean in every mathematical problem, x is always 5. Sometimes x may be 30. Or x may be 15.3. So because the value can change or vary from problem to problem, that is where the idea of the name variable comes from. But in math, simply a variable is a letter that represents one or more numbers. Our next definition is the idea of a variable expression. So a variable expression is a collection of numbers, variables, and operations. Now, what makes an expression different than an equation? And those are two words you'll hear a lot throughout algebra: expression and equation. So an expression is a collection of numbers, variables, and operations. Operations meaning addition, subtraction, division, multiplication, squares, square roots, etc. The difference between an expression and an equation, though, is that an expression does not have an equal sign. If a problem is set up with an equal sign in it, it becomes an equation. If we look at this example down here, example 1, part A, 8y is an expression. 10 divided by y, or 10 over y, is an expression. Y plus 3 is an expression, and so on. If this said y plus 3 equals 12, then that would be an equation. And then our third definition to look at is the idea of evaluating the expression, or evaluating an expression. And what it means to evaluate an expression is that we replace each variable in the expression by its value. So we just simply replace the variable with its value, and then we can simplify and fully evaluate by doing the math. So we'll look at that in example 1. And in example 1, we start with the expression 8y. Now, something you need to know and want to write down and remember is anytime we have a number, and I use the pound symbol for number, anytime there's a number right next to a variable, that is the operation of multiplication. So 8y means 8 multiplied by whatever y is. So if I had a problem that was 12w, that would be 12 multiplied by w. So anytime we have a number right next to a letter, or right next to a variable, that means you multiply the two. So in example 1, they ask us to evaluate the expressions when y equals 2. So every time to evaluate, we'll be replacing y with 2. So 8 times y is 8 times 2, so that gives us a final value of 16. 8 times 2 equals 16. So our answer is simply 16. In part B, 10 over y. Anytime we have a fraction, and this is true for all fractions, simply what a fraction means is top divided by bottom. So if we have 10 over y, that means it's 10 divided by y. If I had x over 5, that would be x divided by 5. So any fraction is always top divided by bottom. So in part B, 10 over 2, we're replacing the y with 2. 10 over 2, which is 10 divided by 2, that would give us a value of 5. Now, I did not rewrite it, but y plus 3, we're going to replace the y with a 2. So 2 plus 3, again, gives us a value of 5. So on your notes, you can write here, 2 plus 3, value of 5. And then in part D, we have 14 minus y. So replace the y with 2. 14 minus 2 gives us a final value of 12. So evaluating an expression means we replace each variable. In this case, each one of these are single variable expressions with its value. Now the next piece we're going to look at is the idea of average speed. And this equation is always how we can calculate average speed. Average speed is represented by distance over time. So distance divided by time will always give us average speed. So in example 2, they give us a word problem, which we can then change into that expression, distance divided by time. So in this word problem, it asks us to find the average speed in miles per hour of a car that traveled 180 miles from Boise, Idaho to the Mendocino National Wildlife Refuge in 3 hours. So we know our distance is 180 miles. We know our time was 3 hours. So to figure out average speed, distance over time, and we're going to replace distance with the 180 miles, time with 3 hours, and 180 divided by 3 gives you 60, and we're left with miles over hours, which reads as miles per hour. So anytime we have a fraction with our units, the fraction reads as the word per. So miles over hours reads as miles per hour. Example 3, they say the perimeter of the triangle is equal to the sum of the lengths of its sides. So if we have sides A, B, and C, the way we find the perimeter of our triangle is A plus B plus C. So that is our expression. So they ask us to find the perimeter of the triangle. So in this case, we know A was 8, B was 15, and C was 17. Got that from our picture. So we're just going to replace A, B, and C with their values, and then add our values. 8 plus 15 is 23. 23 plus our 17 gives us 40 whatever units we're using for the perimeter. So our perimeter would be 40 units. Example 4 is again giving us an expression in the form of a word problem and asking us to evaluate. So it tells us the simple interest earned by money, represented by the capital letter P, which is called the principal, at an annual interest rate R. So the interest rate is a lowercase r. For t, the lowercase t represents the number of years, is given by the expression p r t. So that expression means principal multiplied by our interest rate multiplied by our time. So if we deposit $650, that would be our principal. So P is 650. Our 8% rate, anytime we're doing a percent in an expression, the rule for algebra is we have to write that percent as a decimal. So 8% as a decimal is 0.08. The way that we convert a percent to a decimal is you divide by 100. So 8 divided by 100 is 0.08. And then our amount of time. How much simple interest will you earn after 1/2 of a year? So our time is 1/2 or 0.5. So when I set this up, it's 650 multiplied by 0.08 multiplied by 0.5. And that gives us our simple interest of $26. Then the second kind of concept that we're looking at in this lesson is the idea of unit analysis. So the simple definition and our idea behind it, when you're writing the units of each variable in a real life problem. So that idea of writing the units of each variable in a real life problem ends up helping you determine the units for the answer. This is called unit analysis, and it's also often used in our science problem solving as well. When the same units of measure occur in the numerator and the denominator of an expression, you can cancel the units. So numerator being the top, denominator being the bottom if we're dealing with a fraction. So one way to translate words in mathematics into real life problems is to write a verbal model. So you're taking the mathematics language and you're trying to express it in a verbal model. So we're looking at the idea of unit analysis and a verbal model to help us make sense of word problems and solve them with expressions and getting the proper units. So the key again is this idea of being able to cancel units if the same units are in the numerator and the denominator. So for example, if we had hours on top and hours on bottom, we can cancel out the units of hours. So in example 5, you plan to go hiking in the Jedediah Smith Redwood State Park in California. You probably don't want to go camping right now in the time of COVID out in California, but hey, take your risks if you want to travel. You estimate you'll hike at a rate of 2 miles per hour. So I just underline that because I'm assuming it's going to be a key piece of info. How long will it take you to hike from Holland Hill Road along the Boy Scout Tree Trail and back? So they gave us a map here. I'm going 2 miles per hour, and my route is the Holland Hill Road along the Boy Scout Tree Trail and back. So what I need to do is I need to find our piece right here, our Boy Scout tree trail. So the Boy Scout tree trail is right here. And what it tells us is our round trip distance is going to be 7.4 miles. So then if we look at this, just wanted to double check one thing in the problem. So 2 miles an hour. How long will it take you to hike from the Howland Hill Road along the Boy Scout tree trail and back? So, along the Boy Scout tree trail, into the woods, and back. That's what they're asking. So, to begin with, we have a verbal model here, and I believe that there was actually a typo in the book. Yeah, these are actually... So our round trip distance is actually not our final piece here. The way that this should be is our one-way distance. That's the way that they actually wrote the book workout that I'm looking at here. So that's why I was a bit confused there. So the way we're actually going to look at this, we're going to ignore the idea of round trip, because round trip typically means there and back. So I'm going to change that to say that the distance of the trail, so just the distance from start to finish, is 7.4 miles. So we're saying it's 7.4 miles long, the trail. So it would be 7.4 miles there and 7.4 miles back. And then we know we're also dealing with the rate of 2 miles per hour. So my total distance would actually be, our total distance of 7.4 plus 7.4 is 14.8 miles. Then our 14.8 miles divided by our 2 miles per hour. So in this case, we have miles here, which would be our top, and we're dividing by miles per hour. So we have miles on top and miles on bottom. So the miles will cancel out, giving us just hours. Then 14.8 divided by 2 would be 7.4 hours for our amount of time. Now, in class, what I plan to do is I plan to go over a couple other ideas of unit cancellation or unit analysis with you, and then you will have plenty of time to work on the practice problems. If you get stuck on the practice problems, I encourage you to look back into the lesson, because sometimes there are extra examples in the lesson introduction that I don't cover in the notes. Or also, obviously, if you get stuck, then please come ask for help and I can walk you through whatever you are stuck on. So again, before you take care of the practice problems, please make sure you completed the notes for this lesson, and then you should start on the practice problems.